Okay, first I noticed that we have an inequality. An inequality says that two expressions are not equal. The next thing I know about inequalities is that our final answer will be put into interval notation. That means that we will be using parentheses or brackets, and we could also be using the infinity inside of them to describe the interval on a number line. For this particular problem, the answer in interval notation will look like this: bracket 25, comma 40, and then another bracket. The next thing about this particular inequality is that it is an and inequality, and this means that there will be an area on the graph where these intersect. So if we have our graph here and we have our 2 points, we know that there will be a spot where they intersect, and that's also where you would shade it on the graph. Another rule to keep in mind is the addition rule, and that means that you can add or subtract numbers from both sides in order to get x by itself. Here we'll notice that we'll have to subtract 5 from both sides, and on this one we will have to add 10 to both sides to get x by itself. A few other things to keep in mind when working with inequalities is that a parentheses indicates that an endpoint is not included, and brackets indicate that an endpoint is included. You would be using parentheses if you have a less than or a greater than symbol. If you have a less than or equal to symbol or a greater than or equal to symbol, you would be using the brackets like we did in this here. The brackets and parentheses are not only used when using the interval notation, but also when you're graphing the problem. So here we would be using brackets, indicating that 25 and 40 are both included in the problem. Now let's solve the problem. To begin, we're going to solve each of these separately to get x by itself. So we can remember that the addition rule means that we can add or subtract numbers from both sides in order to get x by itself. So here, we're going to subtract a 5 from this side and also from this side, which will give us x is less than or equal to 40. And then on this side, we'll use the addition rule as well, and we can realize we will be adding 10 to both sides to get x by itself, which will give us x is greater than or equal to 25. Then I realized that with this compound inequality that it is true whenever x is less than or equal to 40 or x is greater than or equal to 25. And since it's an and, it indicates that the graph somewhere will overlap. So keep that in mind as we're working through this. So the next step is going to be to graph these. So we can make our graph here. And we're going to plot our 25 right here. And you can add other numbers if you want, but to make this simpler, I'm just going to put the 25 and the 40 on the number line. And then notice that because it is a less than or equal to 40 sign, and also x is greater than or equal to 25, we're going to be using brackets instead of parentheses, because 25 and 40 are both included here. So we can put our brackets on the number line. And then we're going to shade the area of the graph where 25 and 40 are overlapping, which would be this area right here. The next step is to write our solution set in interval notation based on where our brackets are and the shading is on our graph. So we'll simply bring this bracket right down here, put our 25 in our interval notation, and then you can separate the numbers by a comma, put a 40 in, and then another bracket since we have our bracket on the number line. So our final answer in interval notation would be bracket 25, comma 40, bracket.